Okay, so in this video, rationalizing denominators. We touched on that in the previous one. Now, just to make it clear, what is an irrational number? An irrational number cannot be written as a fraction of one integer or one whole number over another whole number. So 3 by 2, this is a whole number over a whole number, so this is a rational number. Okay, and that means that you have a pattern of repeating decimal places. So it's predictable, whereas root 5 can never be written as a over b, and if you put it in a calculator, the decimal places would change all the time. There'd be no pattern to it, right? So the only way to make an irrational number rational is to times it by itself. So root 2 is irrational, root 2 times it by root 2, and you end up with 2, which becomes a rational number, because remember, 2 is the same as 2 over 1. So, in this case, if we want to rationalize denominators and then simplify things up, we need to look at this like, well, the only way to rationalize an irrational number is to times it by itself. But if I do that to the bottom, I have to do that to the top as well. So root 5 times root 5, remember top times top, bottom times bottom is 5. And now this is a rational denominator. 5, remember, is the same as 5 over 1. So we're done, finished. Now, this part B, this is the crux of the matter, really. We need to get rid of square roots on the bottom. The only way to get rid of square roots on the bottom, when you have 3 plus root 2 or something like that, is to times it by a difference of 2 squares. The reason for that is because you know that a squared minus b squared is the same as a minus b times by a plus b. So you know root 2 squared, because remember here, root 2 and root 2. Root 2 squared is 2, and 3 squared is 9. So there is no remaining root 2's dancing about in our problem. So if we do it to the bottom, we must do it to the top. So remember, if you have on the bottom one term plus another, and if any of those are irrational, just times it by the difference of 2 squares. So top times top, so that's 6 minus 2 root 2, bottom times bottom, so that's 9 minus 2. And you could do it the long way if you want, but you know that that's a difference of 2 squares. Okay? So that becomes 6 take 2 over root 2 all over 7. So now the bottom is rational because 7 is the same as 7 over 1. Let's try that again. This is always something that for some reason students find quite hard. So I see that one of the terms, or at least one of the terms, is a square root. And it's irrational number. I can't simplify that down. So we times it by a difference of 2 squares. Whatever sign is in the middle there, we're going to times it by the opposite. So this will be plus 2 here. So on the bottom, difference of 2 squares, root 3 times root 3 is 3. Minus, it's always minus, 2 times 2 is 4. And then on the top, 3 root 3 times root 3. So 3 root 3 times root 3 is 3 times 3, because root 3 times root 3 is 3, plus 2 times 3 root 3, so 6 root 3. So at the moment we have 9 plus 6 root 3 all over minus 1, which is the same as minus 9 minus 6 root 3. Okay? Done. Is that the last example? It is. Okay. Happy rationalizing.